So we are working in section 3.7, derivatives of inverse functions. And we talked about how to find the derivative of the inverse function at a particular point. And then we talked about derivative of inverse trig functions. So what I want to do today is just kind of a review of all of that. All right, so the first thing is, here's a problem where we're going to actually just, so here's a review. So this was, the first section was P 1.4 and P 3.7. All right, so the first problem I want to give you is I want you to actually find the inverse of this particular function. Given f of x is equal to x, I'm sorry, the square root of x divided by the square root of x minus 3, and here x is strictly greater than 9. Find f inverse of x. So how do you go about finding the actual inverse of this function?
The first thing I would do is make it so those square roots turn to the 1/2 exponentially.
Okay,
Make it a
we
little
could
easier.
do that. We could do that. I'm not sure how that's going to help yet. I would actually just leave it as square root for right now. If we can change it to x to the 1/2. I'm just trying to see how that's going to, okay, well, let's do that. I don't know if that's going to help, but so we have y is going to be x to the 1/2 power divided by x to the 1/2 power minus 3. Okay, so now what are we going to do?
Switch the x and the y.
Okay, so now we're going to switch x and y. All right, so when we go to switch x and y, we're now going to get x is equal to y to the 1/2 power divided by y to the 1/2 power minus 3. Okay, so what's the next step?
Multiply what's on the bottom on both sides.
Okay, why are you doing that? What are you trying to do?
Simplify the equation.
Okay, what's your ultimate goal?
Is the ultimate goal to isolate y?
Exactly. So we want to solve for y. That is exactly right. Okay, So you may know what you're doing in your head. You already have an idea. I'm trying to solve for y, but I want everybody else to know that that's what you're doing. Okay. All right. So now we're going to multiply. Okay. Distribute. And then I'm going to move y to this term needs to move over there. And this term needs to move over there. Okay. So I'm going to get x times y to the 1/2 power. I'm going to subtract y to the 1/2 power. And I'm going to add 3x to both sides. So now I can factor out y to the 1/2 power. And I'm going to get x minus 1 is equal to 3x. So now I get y to the 1/2 power is 3x divided by x minus 1. And so therefore y turns out to be 3x over x minus 1 squared. But there's a restriction. Okay, so let's think about our restriction. All right, because this is over here, when we go back, we said that x had to be greater than 9. So the domain of this function, so what's the domain of f of x? All right, so the domain, so we're going to let this, let me move this out the way. We're eventually going to let this be f inverse of x. And that is going to be 3x over x minus 1 squared. And back over here, when we had f, was the square root of x over the square root of 9 over the square root of x minus 3, we knew x had to be greater than 3. So as x increases, we get the limit as x goes to infinity of f of x. And that's the square root of x over the square root of x minus 3. So that limit is 1. So x will never be 1. That's good for us. Okay. Not only will x never be 1, x will always be less than 1. Well, let me think about that. I might be wrong. If I put a 4 in here, I get, I can't put a 4. So let's put a 16. 16 over square root of 16 over the square root of 16 minus 3. So that's 4 over 4 minus 3, which is 1. Okay. So x will always be greater than 1. All right. So that's our domain. I mean, our range. So for here, we now know that the domain of f of x turns out to be the set of all x such that x is greater than 9. This should be a 9, not a 3. And the range of f of x is the set of all x such that x is greater than 1. So now, as we look at our f inverse, we can now say that the domain of f inverse of x is the range of the other one. So it's the set of all x such that x is greater than 1. So that's going to be the restriction. So the restriction here is x has to strictly be greater than 1. Okay.
Professor,
Yes.
never mind. Never mind. I just wanted to see the last thing you wrote.
You didn't want me to move it?
No, not yet. All right, you're good.
How about I don't move it so far? Okay, number 2. Given f of x equal to 2x cubed plus 1 cubed where the point 127. Okay, so if I put in a 1, I get 3 cubed is 27. So 127 is on the curve of f of x. Find the derivative with respect to x of the inverse function at 27. Actually, let me make it very clear. Let's just do an x here. Evaluate it at 27. All right, so I said given f of x, the function is 2x cubed plus 1 cubed. Now the point 127 is on the curve. So if I put in x equals 1, I get 2 times 1 is 2 plus 1 is 3. 3 cubed is 27. So the point 127 is on the curve. Okay. Now I'm asking you to find the derivative of the inverse function. So the inverse function has the point 27,1 on the curve. All right, what is the slope at that point on the inverse function? So what is the slope of the inverse function at the point 27,1? What do I do?
You find the inverse of f of x.
Okay, so now I can find the inverse of f of x and then take its derivative. So that is one way to do it. But suppose I can't find the inverse of f of x. I want you to do it. So let me say find. So let me add something to the problem. Find that without computing f inverse. Okay, so yes, you are correct, Ezekiel. There is a way that I can actually find the inverse of the function and then take its derivative at 27. But what I would like you to do is I would like you to give me the derivative or of the function, the inverse function at 27, but I don't want you to go through the work of computing f inverse. So we talked about this yesterday.
Is this when you flip y and x?
Okay, so that would, if when I flip y and x, that's the process of actually computing the inverse. So we're not allowed to do that in this problem. So let's go back a little bit. Back before we talked about the inverse trig functions. Back a little bit. And let's see here, there was a formula for us. Okay, so in our problem, A is 1 and f of A is 27. Okay, so f takes 1 to 27. So I want to find the derivative of the inverse function at 27. And it tells me that I need to compute the derivative of the regular function at the A. So let's go back and draw a quick picture. All right, so let's draw a quick picture. So over here is A, which is equal to 1. And over here is f of A, which is equal to 27. So f takes me from here to here. And I can find f prime of A, which is f prime of 1. But what I'm asking you is to find the derivative with respect to x of the inverse function at 27. So I know the slope, I can, so here's the slope of the function at A, which is 1. I'm asking you to find the derivative of the inverse function at over here. So this is f. F takes me this way. And then f inverse takes me back. So to find that derivative, I'm going to get that the derivative with respect to x of the inverse function evaluated at 27, that's my f of 1, is equal to 1 over the derivative with respect to x of the actual function at 1. So all I need to compute is f prime at 1. So we need to compute okay, so that's pretty easy. F of x is 2x cubed plus 1 cubed. So what is f prime of x? How do I compute f prime?
We would make use of the chain rule.
Chain rule, excellent. Okay, you want to go ahead and do it?
So if I remember correctly, the chain rule is f of x times the derivative of g of x times the derivative of f of x.
It's the derivative of f evaluated at g of x times the derivative of g of x. That is correct. So my outside function, so here's my inside function. This is my inside function, which is u, 2x cubed plus 1. So the derivative of the outside function is 3 times that thing squared. Okay, so I have to take the derivative 3 times the blob squared. Okay, so that's the derivative. I know some of you need some refresher on the chain rule. And then I have to take the derivative of what's inside. So now I have to multiply by 6x squared. Okay, anybody rusty on the chain rule? Some of you are going to be a little bit rusty.
I am.
Who is that, Lawrence?
Yes.
Okay, so, all right, so that what I just used was the outside inside rule, which was to differentiate the outside function. So what you need to do is identify, okay, Danye, thank you. You need to identify the inside function and the outside function, okay? So if y, so this is the way I teach the chain rule. Y is equal to 2x cubed.
I'm sorry, can you repeat that again? You said to identify what?
I'm going to show you, identify the inside function and the outside function.
Okay, thank you.
Okay, so y is equal to 2x cubed plus 1 cubed. All right, so we're going to let that be y, and we're going to identify the inside function as u, as 2x cubed plus 1. So now I can write this as y is equal to u cubed, where u is 2x cubed plus 1. Does everybody see that now? So if I let this thing inside be u, then y is just u cubed, and u is 2x cubed plus 1. So the chain rule says dy dx says take the derivative of y with respect to u, and then multiply by the derivative of u with respect to x. So we need to find those things. All right, so if y is u cubed, then dy du is 3u squared. And if u is 2x cubed plus 1, then du dx is 6x squared. So now I just need to plug those in. So I have dy du is this term, and here is dy du. And then I have du dx is this term, and here is du dx. So now I need to put it together. So dy dx.
Where are you getting the 6x squared from?
I took the derivative of 2x cubed.
So what are you timesing that by?
Say that again.
What are you multiplying it by?
So I'm not multiplying it by anything. So here's the function. So if I had given you this function, y is equal to x cubed, how would you differentiate it?
Would it be to the 1/3?
I'm taking the derivative. So I'm using this rule. I'm using the rule that the derivative with respect to x of x to the n says bring down the n and make it x to the n minus 1. So I am using that rule.
So you're
that,
So you're
Go ahead.
subtracting 1 from the top number?
Exactly. So when I take the derivative of 2x cubed, of x cubed, it's bring the 3 down, x to the 3 minus 1, which is x squared. So the derivative of x cubed is 3x squared. That means that the derivative with respect to x of 2x cubed says I can bring the 2 out and get the derivative with respect to x of x cubed. So that's just 2 times 3x squared. And that's how I got 6x squared. And then the derivative with respect to x of the constant 1 is just 0. So that disappears. So that's how I get all of that together. Gives me that the derivative with respect to x of 2x cubed plus 1 is just 6x squared, which is how I got du dx.
Thank you.
You're welcome. So now dy dx is dy du, which is 3u squared, times du dx, which is 6x squared. I didn't even get a chance to simplify the problem yet. Okay, but that's fine. But now I have to put u back in. So that's 3 times u, which is 2x cubed plus 1 squared times 6x squared. So that's f prime. Okay, so notice I got the same answer in both cases. So here, I got that answer, which I haven't simplified yet. But here, I also got the same answer. And I have to simplify that. Okay. So that says that f prime of x, the 3 times the 6 is going to give me 18x squared times 2x cubed plus 1 squared. And I need f prime at 1, which says I'm going to take 18 and I'm going to multiply by 2 times 1. That's going to give me 3 squared is 9. Okay. So 18 times 9 turns out to be 162. All right, so now we have found what we needed. All of that was just to find f prime at 1. Okay, so we started with the function f that was here. All right, Eric said, let's use the chain rule. We came down here. We explained in detail how to take the chain rule derivative. We found that this was the derivative, and then I need to evaluate it at 1. So now I can finish my answer. So to the answer to the problem is the derivative with respect to x of f inverse of x evaluated at 27 is going to be 1 over 162. Okay. Any questions about that?
Just one thing regarding when you were using the chain rule. So when you were the original one, it was, if I remember correctly, it was 3x plus squared plus 1 to the third, something along the lines of that.
Okay, so the original function was
See,
2x cubed
yeah.
plus 1 cubed,
So-
yes.
So the cube part, two things. One, I want to show, I'm understanding this, that the cube part, or the 3 in the upper right-hand corner of that equation, is the f, and two, when finding the derivative of the f, we're supposed to treat that 3 as if it's 3x, based on what I'm
Actually,
seeing.
you do not treat it as though it is 3x. So let me do one more, just another chain rule example. So say f of x is equal to the sine of 6x to the 4th plus 7. Okay, that's it. Okay, so Eric, the outside function is taking the sine of something. So this is what I was saying to you. Identify the inside function. Once you identify the inside function, that is what, from Eric, from what you learned, that is the g of x. So the way Eric learned it was the g of x would be 6x to the 4th plus 7. And the f of x would be the sine of g of x. So then when you take the derivative f prime, you would take the derivative of the sine, which would give you the cosine of g of x, but then you'd multiply it by g prime of x. So you would get f prime of x would be the cosine. G of x is 6x to the 4th plus 7. And then you take the derivative of that, which would be 24x cubed. So Eric, that's how it sounds to me like your professor from Calculus 1 used the f and the g. So you would get f prime of g of x times g of x. Now, the way I teach it is slightly different. I have y is equal to the sine of 6x to the 4th plus 7. And it's very similar to what you learned. So I'm going to identify the inside function, and I'm going to call it u. So I'm going to call it u is going to be 6x to the 4th plus 7. And then I can write y is the sine of u, because u goes in there. So this just goes inside there. So y is the sine of u. So now that I identified my inside function as 6x to the 4th plus 7, and my outside function as y is equal to the sine of that thing, I can now find dy du. Derivative of the sine is the cosine of u. And then I can find du dx. And the derivative of that is 24x cubed. So now dy dx is dy du times du dx. That's the chain. Dy du is cosine u. Du dx is 24x cubed. So I would put the 24x cubed in the front, because we normally put polynomials in the front. And then I would write this as cosine of u, which is 66, no. Cosine of u, and u is, oh, that's right. U is 6x to the 4th plus 7. Okay. Okay. So I need to take the derivative of cosine inverse of x cubed times the cosine inverse of 9x. All right, so stick that in there just so you can see. This is a product rule. All right. So f prime, going to take the derivative of the first and we get 3x squared times the second, just as it is. Plus the first, which is x cubed. And now here comes the hard part. We have to take the derivative of cosine inverse of 9x. So we need to take the derivative with respect to x of the cosine inverse of 9x. Now, normally when I solve this, I just solve the whole problem straight through. But for those that may still have some trouble with taking the derivative of the cosine inverse of 9x, I'm going to actually do it separately for you. Okay. So the first thing is we got to remember that the derivative with respect to x of the cosine inverse of u of x, well, that's -1. Remember, the co's are negative. -1 over the square root of 1 minus u of x squared. And then I have to multiply by du dx on the outside. So therefore, the derivative with respect to x of the cosine inverse of 9x is going to be -1 over square root 1 minus 9x quantity squared. And then the derivative of 9x, well, that's not hard. When I go to take the derivative of 9x, I just get 9. Okay, so now I can take my problem and stick all that in and get the f prime of x is 3x squared times the cosine inverse of 9x. I already know I'm going to have a negative. So it's going to be negative. I'm going to take this 9, multiply that x cubed and get 9x cubed. And then in the denominator, I'm going to get the square root of 1 minus 81x squared. And I'm done. So what I did was I separately said, oh, that cosine inverse of 9x, that derivative looks a little hanky there, a little scary. So let's do that separately. So class ends in 10 minutes. My office hours start in 20 minutes. So if anybody just wants to stay on, you can. I'll probably take a 5-minute break and come back. Okay, so I found the derivative of cosine inverse of 9x separately, and then I multiplied it by the x cubed, and so that's my answer. Okay. Any questions? Okay, I want to do another one. Given f of x equals tan inverse of x. Let's make it easy. I won't make it too tough. The tan inverse of x to the 4th power. Find f prime of x. So now I have a chain rule going on. Anybody want to attempt to help me here?
Well, for starters, if we're going to make use of the chain rule here, we should start by placing 4 and then placing parentheses.
Okay, good. So I get f prime of x. Says bring down the 4 and take that whole thing cubed. Okay, so that is the first step. Agreed. So 4 times what's inside cubed. So now what's the next part? I got to take a derivative. The derivative of what? It's like opening up. So when you unwrap a gift, it's like you have the first piece of wrapping paper, and then suppose somebody got smart and put another piece in there, or there's a gift inside. So you take and you have to unwrap it. That's the derivative of the outside, but then you have a gift inside. So you have to take the derivative of that as well. So we took the derivative of something to the 4th power. That becomes 4 times that thing cubed. So we did that part. Now the next part is to multiply by the derivative of tan inverse, otherwise known as arctangent. Okay. So the derivative of arctangent, that's one of my favorites. That's a nice, easy one. That's just 1 over 1 plus x squared. So you get 4 times the tan inverse of x cubed divided by 1 plus x squared. And that's the end of that problem. Okay. Find f prime of x if f of x is equal to x cubed times the secant inverse or arc secant of x cubed. Actually, we know how to do the product rule. I don't even feel like it. Let's just do the derivative of the secant inverse of x cubed. All right, so we have to use the fact we remember the derivative with respect to x of the of the arc secant of u is 1 over, we're going to have an absolute value of u, and then we're going to get the square root of u squared minus 1. And then we have to multiply by du dx. So let's use that and get an answer. Somebody tell me what what x prime is going to be. F prime is going to be.
Would the f prime be the thing you just did up there with the secant inverse?
Okay, so we're taking the derivative of the secant inverse, yes. So the only difference between here, the only difference between these two pieces is that in this piece, u is x cubed. Does anybody want to try to give me an answer, or are you guys stuck? Because it's quiet.
Um, we could, so I think the answer would be, not simplified, would be 1 over absolute value of x cubed times the square root of x cubed minus 1
Okay, so
times,
wait a minute, 1 over, so let's get that part. 1 over, say it again, the absolute value of x cubed, good.
Mhm.
Keep going.
times the square root of x cubed minus 1.
Okay, I have to square that. Because the u is squared. Do you see that, Eric?
Mhm.
The u is squared. Okay, minus 1, and then I have to multiply by one other thing. What else do I have to multiply by?
Three x squared.
Yes, 3x squared. Okay. All right. Okay, I hope everybody had opportunity to log into quickly and put in their attendance.